Okay, welcome back. In the last video, I mentioned that there are many benefits of using Platform IO, and that's a more professional tool which have many perks over the traditional Arduino IDE for development and making IoT solutions and writing firmware for them. So one of those benefits is going to be elaborated very soon in this video. In this video, what I'm going to do is I'm going to interface our digital humidity temperature sensor DHT11 with ESP32 board, right? And later on in the next couple of few videos, we are going to upload that value to the cloud. Well, so what we need for this project, we need two things. We need the ESP32 itself, and we need the DHT11 sensor, right? So how I have connected is that I have connected the ground pin to the ground pin, the VCC pin to the VCC pin, and the digital pin of this sensor to GPIO21, right? If you place the ESP nodemcu board in this location, in this placement in front of you, this is exactly how it's going to look, and this is going to be the pin number D21. Okay, well, this particular pin is no connect pin. Okay, so you don't need to connect to this pin to anything, and more of a usually we get a PCB which gives us the output of just 3 pins, right? So it's mentioned on the PCBs that it's VCC, ground, and the digital output. Okay, so let's get back to the code and let's talk about the benefit. Okay, so if I try to make this project on Arduino IDE, what I need to do is I need to manually download. First, I need to search the library support for this particular sensor, right? The library from Adafruit or any other off-the-shelf library, right? I need to go here. I need to set up the libraries. I need to search that, or it's very much possible for some particular, like I have to go here, right, to the library manager, right, include libraries, and then I may need to search it on Arduino, or I may need to manually import that library. The issue with that approach is, first of all, it's hectic. The second thing is that if you want to ship this solution to someone, or if you want to collaborate with another developer writing code with you, you both need to have the same libraries, right? So library version controlling is an issue, right? What we're going to do right now is we are going to make use of the collection of libraries provided by Platform IO community, and then I'm going to show you the benefit that your developer partner don't need to do that hassle of installing or setting up the environment at his or her end. Okay, so first thing first, we need a library for DHT11 for ESP32, right? So for that, what we do is we come here, we go to the library section, and we write DHT11, right? And now Platform IO is going to search libraries for you, right? They turn a lot of support. I go to the very first library, and in fact this is the one I'm using, and I have actually taken example code from provided by the developer available here, right? And now I understand now, if I think that this is a suitable one, and in fact it is a suitable one for my project, and I want to incorporate this into my project, all I need to do is I need to click here, add to the project. Then I need to select the particular project. In my case, I have selected the project, this first one, the Hello World one, right? The project which we created in the last video. Then I copied the code from here, and then I came here. I actually did some modifications to that code. I elaborated the code as well. But now what those steps have done or resulted in is that it has added this particular line here, right? So if you want your team to collaborate with you in firmware development, that other persons don't need to worry about that particular version and that particular library. Okay, this ini file is going to take care of everything. All you need to do is to ship this entire folder, project folder, to your partner, and once he or she is going to click the compile button, Platform IO is going to search for this particular library, this particular version. It's automatically going to install it. Okay, so you don't need to have a bunch of libraries installed on your system. There's another benefit to this approach is, and that is that Usually we face problems where the code of Arduino is compiling on one system and it's not compiling on another system, right? The reason is that we kept on installing libraries and throughout our development for different projects, and we already have some libraries installed, and sometimes we have different versions of those libraries installed. This eliminates that issue entirely. Okay, so talking about or praising a lot about platform, coming back to the project, right? So talking about the hardware, we already know that this is the brief hardware. All we need to do is to print the value, right? Okay, so first thing first, this is included. This shows that this is going to make use of the Arduino library, right? The Arduino support for platform IO. Next, these strings came from the example code I copied. Just ignore it for the time. Okay, now I include three libraries: the Adafruit sensor, dht.h header, and dht_u header. Okay, next, making use of this code, I need to specify which digital pin I have connected the D output pin of my sensor. Sorry, in the beginning of the video I mentioned it's D21. It's in fact D23, right? So that means that if you place the board like this is going to be 23. Okay, then there's a support of both of the sensors, DHT22 and DHT11, and even DHT21. Well, it's new for me as well that DHT21 is out there. So basically, the higher the number is, the more the accurate output is, right? But the code is going to be the same. Okay, so in my case, I have the cheaper variant, that's DHT11. So I commented out this portion and I uncommented out this portion, right? Again, some referencing to the developer's data, right? Now you need to tell this particular library while creating an object that which type of DHT you have created and which pin you want to associate the output to. So these values comes here, and then there's a variable declaring that is going to be used for delay. Okay, coming to the setup part. In the setup part, what I'm doing right now is, or what actually that developer did is, he or she is printing the details of this sensor. So for that, we need to create an object of sensor type. So this also come from that header, and then we fetch the value details of that sensor. So this is going to print the details of that sensor. It's going to print the type of the sensor, temperature sensor and humidity sensor. That's a part of our module. Coming to the loop. So what we are doing here is we are creating an event of sensor type, and then that event we are first calling the event of temperature. So if there is no output received, it's going to come here and it's going to print that we are getting an error in reading the temperature value. But if that's not the case, we will come in the else and we are going to print the temperature value. So in my room right now, the temperature is 17.5 degrees Celsius. Right, exactly the same thing for humidity. Humidity is right now around 92%, right? We are going to call the event of humidity, and if we are getting the value, some valid value, we are printing that. That's it for the code. Now click the upload button. Well, the code was already uploaded, just for your reference. I click the upload button, and I think I need to change the permissions. Okay, well, you need to do this permission thing for Linux. Done. So the output is the code is uploaded there, and we are getting the output in the serial monitor, right? Thank you very much. This is for this video. In the next video, we are going to upload the value of humidity and temperature to a cloud, right? So it's a series of Internet of Things. We are going to get involved internet into our project in the next video. Thank you very much.